Let us write down the value of a1 by a2, b1 by b2 and c1 by c2 in the table below by comparing the pair of linear equations to their standard form, which is: what relation do you observe between the ratio of their coefficients and the graphical representation? Here, we observe that when a1 by a2 is not equal to b1 by b2, that is, the pair of equations has a unique solution or is a consistent pair of equations. Take the second set of linear equations in two variables. We observe that a1 by a2 is equal to b1 by b2, that is equal to c1 by c2, in the case of a pair of linear equations which has infinitely many solutions or is a dependent, consistent pair of equations. In the third set of a pair of linear equations which has no solution or is an inconsistent pair of equation, we observe that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. Let us summarize the ratio of comparing the coefficients, its graphical representation, and its algebraic interpretation for the different pairs of linear equations. So, given a pair of linear equations in two variables, we can find out the type of solution the equations will have by just comparing the coefficients of the two equations without any calculations or plotting on the graph. A pair of linear equations in two variables with the standard form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 intersect if a1 by a2 is not equal to b1 by b2. Coincide if a1 by a2 is equal to b1 by b2, that is equal to c1 by c2. Parallel if a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. Find out whether the pair of linear equations 3x plus 2y is equal to 5 and 2x minus 3y is equal to 7 intersect at a point or are parallel or coincident. Also, find whether they are consistent or inconsistent. Here, the given pair of linear equations are 3x plus 2y minus 5 is equal to 0 and 2x minus 3y minus 7 is equal to 0. Can you predict the behavior of pair of linear equations without drawing graph? Yes. To find this, let us compare the coefficients with the standard form of the linear equations ax plus by plus c is equal to 0. Taking the ratio of coefficients, we find a1 by a2 is equal to 3 by 2, b1 by b2 is equal to 2 by minus 3, and c1 by c2 is equal to 5 by 7. Here, we observe that the ratio of coefficients of the pair of linear equations are not equal, that is, a1 by a2 is not equal to b1 by b2, which is also not equal to c1 by c2. Thus, we can conclude that the given pair of lines 3x plus 2y minus 5 is equal to 0 and 2x minus 3y minus 7 is equal to 0 are intersecting and have a unique solution. So, the equations are consistent. Find the value of k such that the system of equations 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0 have no solution. Here, the given pair of linear equations are 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0. Comparing the coefficients with the standard form of linear equations, we get a1 is equal to 3, a2 is equal to 6, b1 is equal to minus 1, b2 is equal to minus 2, c1 is equal to minus 5, and c2 is equal to minus k. We know that the condition for pair of equations to have no solution is given by a1 by a2 is equal to b1 by b2 is not equal to C1 by C2. Substituting the coefficients in the above equation, we get 3 by 6 is equal to 1 by 2 is not equal to 5 by k. Or 1 by 2 is not equal to 5 by k. This implies k is not equal to 10. Thus, for a pair of linear equations, 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0 have no solutions. The value of k cannot be 10.